discuss inverse functions, and the idea of the inverse function depends upon one-to-one functions. So if you need to learn what that is, I have a video for that. Please look for it. But here we have an illustration where we have a domain and a range. Okay, so I'm going to draw a function. Remember, it takes an input, maps it over to an output. We'll call this f. Now, let's also think about going backwards. That's what we really want to do. So think for a moment, if this thing was not one-to-one, so in other words, if I had two inputs that go to the same output, that means it's not one-to-one. If I try to go backwards, all of a sudden I don't know which direction to go. In fact, if this is my input, then I have one input going to two outputs. That breaks the definition of a function. So that can't happen. Alright, so what we're going to do is we're going to let f be one-to-one. That means every input goes exactly one output. Okay? So no two inputs go to the same output. Then when we think about it in those terms, now all of a sudden we can go backwards. And this act of going backwards is what we call the inverse function. And it's denoted like this. F to the negative 1. And I want you to make a note. Here's a very common mistake. But note, f to the negative 1 does not mean the reciprocal of f. Okay, that's true in real numbers. That's true when we write polynomial exponents. But this notation here means the inverse function. Okay, inverse function. Alright, now let me give you an example of one. So let's let f of x be x plus 1. So that means if I pick 0, for example, and I plug it into my function, 0 plus 1 goes to 1. Now, can I think of a way to go backwards? Yes. F inverse equals x minus 1. So now, if I plug in 1 on this side, and I go through x minus 1, I will travel back to 0. And that's not unique with 0 and 1. Pick your favorite number. If I pick 10, for example, 10 into f goes to 11. 11 into f inverse goes back to 10. Okay, so that's the idea. The f inverse undoes the function. So how do you find an inverse function? I'm going to go through some examples along with some steps, and I hope this makes sense. Okay, so for our first example, I want to find the inverse function of f of x equals the cube root of 3x minus 1. So in other words, I'm trying to undo the cube root of 3x minus 1, get back to where I started. So how do I do this? Alright, so here we have some steps. Your first step is to replace f of x in the definition of f with y. So we take it outside of functional notation. Okay, so far so good. Step 2, this is the money-making step. This is the magic step. This is where it happens. Okay. Step 2 is you interchange x and y in your equation. So in other words, wherever you saw x, you write y, and wherever you saw y, you now write x. Now I'm going to pick a different color because I want to point out that now I don't have the same function I did any longer. In fact, these two functions now are inverses of each other. Okay, so I now have x equals the cube root of 3y minus 1. Step 3 then is to solve this equation in terms of y. Okay, so we got to get y equals. So how do I get y equals here? Well, first I'm going to cube both sides. So if I cube the cube root of 3y minus 1, I just get 3y minus 1 equals x cubed. Okay, now I can easily solve for y. I add 1 over, and finally divide by 3. I have 1/3 times x cubed plus 1 equals y. The last step here is now let's get it back into functional notation, and we'll replace y with f inverse. So f inverse of x equals 1/3 x cubed plus 1. Okay, now if you doubt yourself here, let's just quickly do our little diagram here. And if I plug in 0 into f, okay, so I plugged in 0 into f, what does 0 take me to? That is 3 times 0 minus 1. The cube root of negative 1 is negative 1. Now let's take that guy and let's plug it back into f inverse. Hopefully we're going to get 0. So if I plug in negative 1 into f inverse up here, I have negative 1 cubed, which is negative 1, plus 1, which is 0, divided by 3 gets me back to 0. Okay, so f inverse did get me back to where I was. Alright, now let's use those same steps to go over a couple more examples. Okay, so I picked these 3 examples to kind of show you all the different caveats here. So for part B, we have h of x equals x plus 3 to the 5th power minus 1. Okay, so remember the first thing we need to do is to take out functional notation. Alright? Step 2 was what? The money step. This is where we interchange x and y. So I'm going to write x equals y plus 3 to the 5th power minus 1. From this point, we need to solve for y, and that was part 3. Okay, so now, and again, remember, these two functions are different now. Okay, so they're not the same thing. So I have x plus 1 equals y plus 3 to the 5th power. How do I get rid of the 5th power? I take the 5th root of both sides, and then I just subtract 3. So I have the 5th root of x plus 1 minus 3 equals y. Lastly, I just put it in inverse notation. So f inverse is the 5th root of x minus 1, or x plus 1, minus 3. Make sure you don't put that minus 3 underneath the 5th root. So there it is. Okay, there it is. Part C will do the same thing. Just want to show you the algebra. So here we have g of x equals x minus 1 over 3x plus 2. Okay, first thing we need to do is take it out of functional notation. And then I interchange x and y. Now this is the first time we've had more than one y. That's okay. I'll show you how to do it. Now we got to solve for y, right? So I'm going to multiply both sides of this equation by 3y plus 2, like that. So I have 3y plus 2x equals y minus 1. Okay, so now what I need to do here is distribute my x. So I have 3xy plus 2x equals y minus 1. From there, I need to get all my y's on one side and anything that doesn't have a y on the other. So I'm going to have 3x y minus y equals a negative 2x minus 1. The reason you do that is because now on the left-hand side of my equation, I can factor out a common factor of y. So I have y times 3x minus 1 equals negative 2x minus 1. And finally, I can divide both sides by that 3x minus 1. So I have negative 2x minus 1 divided by 3x minus 1, like that. And so finally, we'll put it in functional notation, f inverse, and actually this is not f inverse, this is g inverse, equals negative 2x minus 1 over 3x minus 1. And there we have it. And actually on part B here, this should have been h inverse as well. I just put the wrong notation. Okay, I hope this makes sense. Inverse functions are very useful. Understanding this process is a great tool to have. If you have any questions on it, I'd be glad to help. Thanks for watching.